All right, hi everyone. So this is now our next lesson, and we will be now on um, 2.3, which is going to be about Venn diagrams and set operations. So for this particular topic, we will have several objectives. So we have several definitions, the universal set, we're going to do the Venn diagrams as well, using Venn diagrams to visualize relationships between sets. Complements of a set, we're going to find a complement, intersection, and union of two sets. We're also going to work on some operations, and then we will be covering also the meaning of and or when it comes to sets. All right, so first things first, we have what we call as the Venn diagram, which you are very much familiar with. You probably encountered them once or not just once in your school life. So when we talk about the universal set, this is the general set that contains all elements under the discussion. Okay, so usually our universal set is represented by a rectangle, I should say. So these are all the elements, okay? All the elements in the general set. Now, each circle or other shapes that you see inside a universal set are what we call as the subsets. So here, some parts of the universal set belong to a certain set called A. Okay, so the reason why it's called Venn diagram is because John Venn created these diagrams to show visual relationships among sets. So let's take a look at how we can identify the elements of the sets that are mentioned here. So let's have the universal set. So we can just use the the roster method to identify what are the elements inside the universal set. So anything that you see inside this rectangle is an element of the universal set. So that would be the square, the triangle, the dollar sign, the letter M, and then the number 5. Okay, so those are all the elements. Why are we not including A? A is the name of this subset here. All right, now taking a look here, what are the elements of set A? So you just have to look at the figure that represents set A, and in this case, everything that you can see in this circle. And you only have two elements in there, the square and the triangle. So those are the elements of set A. Now, last question here. The set of elements in U that are not in A. Okay? What are the elements that are inside the universal set but are not found inside the circle? So you can see that all the other elements that are not in the circle are actually this 3 over here. So that's your dollar sign, the letter M, and the number 5. Okay, so that's how you can use your Venn diagrams. Now, we can represent sets inside your Venn diagram, inside your universal set, if they are separate. Okay, they are what we call as disjoint sets. So there are no elements they have in common. Okay, so for example, set of even numbers and set of odd numbers, they will never overlap. There's no common between them. Now, if everything inside one set is also found in the bigger set, then this is the representation of a proper subset. It means all the elements in A are also found inside a bigger subset, which is B. Equal sets, on the other hand, because pretty much they have exactly the same elements, then they are just representing overlapped circle, like it's exactly the same circle. Okay, now when you have sets with some common elements, that is when you will have some overlap. Okay, so let's say we have set A and then you have set B. So anything here in this darker shade region, those are common elements, meaning the elements here are found in both A and in B. Okay? So let's take a look at this example. Okay? Now, one thing that I would like to emphasize here is that the Roman numerals here, the 1, 2, 3, 4, you can use them when you are being asked of the area. Okay? So area 1 is, area 1 is this part. Okay? This is area 2, and then this is area 3, and then everything else is area 4. So that's what those areas are talking about. Okay? So here, it's either in identifying the elements, you can either use the roster method, or we can also use the Roman numeral to represent which area we're talking about. So universal set, again, everything that you are seeing inside the rectangle, so you will have it as A, B, C, D, E, F, and G. Everything inside that rectangle. Now, what are the elements inside set B? Set B is this circle here, okay? So set B is that circle. What elements do you see inside set B? So that would be D and E, okay? So if it will help you to redraw the whole thing on a piece of paper so that you can better understand what you are looking for, do that. It would be more helpful if you can redraw it, and then if you need to like redraw that particular part, you can do that, okay? The set of elements in A but not in B, okay? So all the elements in A are represented by this circle here, okay? But we are looking for the elements in A but are not in B. So they should not be in B. As you can see, B and A overlapped in this area, which means D is also part of set B. So what are the elements in A but not in B? So that would be your A, B, and C. All right, so that's how you can work it out. Again, if it helps you to draw the whole set thing, okay? Now, let's take a look at the next one. It says here, the set of elements in U that are not in B. So, in U, not in B. So, everything that are in U, so everything that you see inside the rectangle, but they should not be found in B. So the easiest way to get that is to identify which elements are inside B. So these are all the elements of B. Anything inside the rectangle that is outside of the circle satisfies this next example. So that will be A, B, C, and then you have F and G. All right. So next thing, the set of elements in both A and B. Both A and B. So let me just erase this one here. So for this one, the elements that we're talking about must be found inside A and B. And so we are basically pertaining to the overlap. So this area here is found in set A and also in set B. So the answer to letter E here is D. Okay? So that is how you can find the different elements being asked about based on your Venn diagram. All right? So one of the common things that we have been hearing here in this particular example is that we are highlighting some parts that are not in a specific set. So we have what we call as the complement. Okay? Oops, sorry, my bad. So when we talk about complement, just think of it as something that is not in that particular set. Okay? So if we are going to visualize it, okay, we know that this circle is set A. Anything inside the circle is belonging to set A. Everything that is outside of that circle, that is what we call as a complement. All right? So whenever you see the name of the set, let's say set B, and you have an apostrophe right by it. So that means you read this as the complement of B. The easiest way to interpret that is what are the elements that are not inside set B. Okay, so this shaded area outside of the set that you are given. Okay, so let's take a look at this example. So we have our set U, our universal set from the numbers 1 up to 9. And then set A, as you can see, is represented by 1, 3, 4, and 7. So now we have to find A complement. So the complement of A will be all the things, all the elements that are not in set A. So 1 is there. How about 2? 2 is not here. So 2. 3 is there. 4 is there. 5, is it in set A? No, it's not. 6 is not on set A. And then you have 8 and also 9. Okay? So if you are not given a Venn diagram, you just have to always compare set A to the universal set. Remember, universal set is the biggest set. So anything that is not in set A can be found in the universal set. If you have your Venn diagram, it's easy. You just have to remove everything in set A. So you will see that these are 2, 5, 6, 8, and 9. Okay?